Yeah. So before we begin, one of the main things I wanted to cover in this talk was, let's say you have a REST API and you develop these little bundles of software that allow end users to make API calls more easily. Do you call those things SDKs? Do you call those things client libraries? Can we get a show of hands for SDKs? Nobody. Show of hands for client libraries? Also nobody. So yeah, very split field. Cool. So I've always wanted to do a good, the bad, the ugly theme presentation, and so you get to see what 30 minutes of keynote animations look like. Imagine some yesteryear world of Western ideals, I guess. The thing that I'm supposed to be describing here is that we went through a process of identifying how we want to build our SDKs not too long ago, and figuring out what sort of strategies other companies use. This is the learnings from that. I'll be diving deeper into what we ended up choosing, which was SDK generation. So in case you guys didn't hear it in the beginning, I work at Square. If you're not familiar with our org chart, I'm going to give you a little rundown. We have a bunch of other big parts of the company, and then we have developers where I am. Oh man, I got so much louder all of a sudden. So I work there, and one of the interesting things about our developer platform team, which is what we're called, is that we don't actually make any of the APIs that our end users consume. All these guys do. So our team handles things like, authentication, doing the documentation, the developer portal, handling OAuth, anything that an end user that's external from our company might want to use for our APIs, but maybe isn't as applicable for internal use. So one of those things is our SDKs. I hope you guys love this sound because you're going to hear it a lot. One of the reasons I'm harping on SDKs so much is that looking from the end user experience, right? An end user, as a product owner or a company, you might think that APIs are what you produce. I'm creating this RESTful service that other people are going to use. But in reality, whatever people can pull down from their favorite package manager is the end user experience. And so if you have a bad experience there, welcome to their competitor. Somebody else is going to move along to find someone else who can give you a good experience there. So that brings me into my first SDK generation technique called HOPE. So companies of all sizes, and this is something that we are very guilty of at Square, is our development team for the APIs is fairly small, and we want to release new features. We want to release new functionality. We have new endpoints we're working on. We love doing that. We don't love doing so much tooling around our APIs or maintenance around our sample apps. And so, any company of any size is sort of guilty of that. And so, one technique that we saw people using is, HOPE, building a little stub of an SDK, hoping that somebody in the world of GitHub or your open source or existing developer community jumps on that and just writes all that code for you. In reality, this causes your developers to not really have any experience with an SDK, right? You can get an SDK that somebody wrote 60% for their application, and then the other 60%, or 40% is just empty, The next person who comes along writes another 60%, it's a different overlapping 60%, uses different idioms, different language. Your experience just becomes super fragmented. The company I was previously at, if you search for product PHP SDK in GitHub, there's 4 pages of results. Only 2 of them are forks of each other. And so you have a just wide berth of experiences that you aren't in control of. And as an end user, you're not really helping them find the right experience for them. So there are ways you can do this properly. You can make the people who make these open source contributions to your SDKs sort of, show them on your documentation, turn them into evangelists themselves. Highlight one open source SDK and make everyone else contribute to that one. You can do this correctly, but that was something that we decided was not going to work for us. The next technique I like to call bespoke, handcrafted artisanal SDKs. Great logo there. So the solution seems to be, why don't you just start making all these SDKs yourself, right? Like just hire somebody to write your Java SDK. That's great. But this person maybe doesn't know Ruby, right? It's like, well, that's easy. One more headcount. But if you're creating this bespoke, awesome experience in each language, it's hard to have super great depth of knowledge in each programming language. And so maybe if you want to do Python or PHP, you're going to need a couple other people. But now you have a core dev team that's already working on releasing new features and new endpoints for your APIs. And so you have all these people releasing new SDKs. Like, what about somebody to sort of align all those documentation pieces, or maybe somebody to write the Go SDK or Haskell, or what about a community manager to handle all the issues that people are filing on GitHub for your SDK? It's sort of like a population explosion when perhaps your team is not that big to start with. So this was something that we would have loved to have done, but we do not have enough money to hire all these smiling faces. And so that was something that we decided not to do either. And so how do you get the best of both worlds? How do you get an experience that is both good for your end users, but also doesn't require you to have sort of the resourcing of a gazillion-dollar company? Leading us to our third sound clip, the generated. So we use SDK generation. It all sort of starts with our specification file. Here you can see it in its entirety as it loops through for 15 seconds. It's a few thousand lines long. And so the specification file sort of describes all aspects of your API. And from what the endpoints look like to some metadata, we actually use the Open API specification. It's formerly known as Swagger. So if you look around on the internet, Swagger has like really good SEO for it. Open API is a little bit harder. So you might have to look for both the terms as you explore. There's other specification formats out there, such as RAML or API Blueprint. Definitely explore those options if this is something that you're interested in, because the tooling around each ecosystem is a little bit different. We chose Open API specifically for some tooling that I'll mention in the future, but there's other options out there for sure. Just to give you an example of what some of that specification looks like, it's a JSON file or YAML file. Here you can see some metadata about our API. You can have some versioning, some contact information. You can see what license or terms of service you need to be using. This is an actual part of our endpoint, and so at the top you can see this is actually the URL. So it's connect.squareup.com/v1/me/employees. That's the URL. You can see the HTTP verb that you use underneath. It's a post request. And then there's some metadata there around what the input does and sort of real words that gets exposed to the SDKs and also to some documentation. And then you can see sort of what you need to pass into it. And so here we're giving it employees object. So this is for creating an employee. There's other stuff that you can stick in there as well. So the Open API spec has some tooling around authentication. We used OAuth, but API key is also supported. You can see our external documentation. So think of how nice it would be if when you're in SDK and you're like, oh man, like where can I look up more info about this endpoint? Well, you can just stick that right into the SDK itself. That's nice. And then you can see here what kind of responses you get in the back. You get an employee object back after you're creating an employee. Isn't that great? You can put a bunch of more stuff in here. It's like example responses, what happens when you get an error back. It's really pretty expressive, depending on if it matches how you designed your API, which is one of the challenges. And so we actually publish this publicly. You can go on GitHub, see our spec. And then also on GitHub, we have a bunch of repos for all of our SDKs. Currently, we have 5 first-party SDKs. And that'll be more important later. So remember our org chart. I'm sure you guys studied it very carefully. We don't make the APIs, right? These guys do. And we actually use protocol buffers to communicate with all of our internal services. And so it's a really useful tool set for us. But each of our internal services communicate with each other, and that contract is defined in proto files. And so we have these files that sort of innately define how our services communicate with each other, right? And so we actually take those proto files, and we actually just have another tool that we've cleverly named Java tool, and turn those into our API specification. And so this is really important for us because we have a lot of people upstream from us making these proto files. And so whenever changes occur in any way, let's say employee is changed, right? We can just sort of automatically change that or reflect that change in our specification without having to do any manual tooling, right? So we're not a bottleneck to other services upstream creating any changes, which is very important to us. And so then we get into the star of the show, which is a tool called Swagger CodeGen. Swagger CodeGen is an open source project that takes your specification and turns it into SDKs, basically. How it works, you have your specification, like I mentioned, then you have a series of templates. And so these templates are made with a framework called Mustache. And Swagger CodeGen just basically takes your specification, applies it to these templates, and out pops an SDK. You can also do some configuration right there, and I'll show you a little bit more about how that actually looks. And so in our case, we make 5 SDKs with that. And so what we used to do is that every time we saw a change in our upstream protos, we'd regenerate the specification, and then somebody would just download Swagger CodeGen on the laptop and just start popping out SDKs that we pushed. As you can imagine, that manual process right there was bad. It was actually terrible. Swagger CodeGen is a very active project, and so a lot of things change very quickly on it. So if you don't generate all the time, it's going to be an issue for you. So the co-star of our show is Travis CI. So Travis, I'm sure most of you guys are pretty familiar with it. It's a continuous integration framework, works really well with GitHub. And so all of our work is actually done by Travis now. So we actually take our specification repo, and we actually check in these templates and config files as well. And so in the same repo, you can see all the templates that we use, all the configuration files. And one thing, like I mentioned, Swagger CodeGen is a pretty active project. If you don't check in your templates, things are going to break unexpectedly because Swagger CodeGen will just use the latest and greatest templates that are out there. So if you don't sort of manually make sure that those things work, you're going to have an issue there. But this is sort of one of our repos, and so the config files, they're just little JSON files that talk about, for Ruby, right, you can specify your Ruby gem name, or you can talk a little bit more about versioning, or if you have like a special model name for something, you can stick that in there too. They're very small JSON files. So what does Travis do for us? Well, quite a bit. I'm going to break out each little section here. And so the first part is actually just installing Swagger CodeGen to the Travis machine. So, and you can actually see all this in our GitHub repo. Travis files are pretty public. So we take a script to just download the latest version of Swagger from the Swagger CodeGen project, the Git repo. Then we compile it with Java and build it there. This line is a section about decrypting some secrets. And so Travis CI has some built-in infrastructure for encrypting secrets. It's kind of tricky because you can never see your secrets again, so it's a little bit harder to use on a team, right? Because only one person really knows the secrets. So basically we keep some deploy keys in a zip file or tar file, and then we decrypt those on the build machine. And then we have a script that generates all of our SDKs. Here you can see the actual script. It's pretty easy. We just have a list of all the languages that we have. And this is like Swagger CodeGen. Generate, you tell what your spec is. So that's our API specification file. You describe what language you're using, whether it's PHP or Java or Node, Ruby, whatever. The config files, the templates, those are all in that same repo. And then we just stick it in a folder. And so Travis CI then goes through and builds all of the SDKs for us. And then the next part is just taking these SDKs, and Travis CI actually pushes the outputs to each of our other Git repos. And so here we've gone through a process of somebody changed some upstream proto for us. We generate an API specification, and then as soon as we make the pull request for that, we have Travis CI pushing out all of these new complete SDKs to the Git repos. And then we have a process around making sure that these look correct. So one of the awesome things that we've done is that we generate, we run our tests on pull requests too. And so let's say I have a new idea for a change to the template. And so I want to make a little template change that pushes, a different type of link in or something. And so I make a pull request for that. Travis CI then generates all the SDKs, pushes them, makes those a new branch in all the SDK repos, and I can actually just use the Git compare features to see oh wow, I made the change in this template, and here is what the actual SDK looks like. Or you can actually test that SDK out by just pulling down the branch, and so that's been very helpful for us. That's been the most exciting part of this whole process, is that you can make a change to the specification or template that's minor and see how it propagates throughout the whole system. So that's been great. And so after we see these new SDKs, we say, hey man, that looks great. We merge them into master. We also use Travis CI to do a bunch of the testing on our SDKs. And so you can imagine once the SDKs get pushed to their individual repos, then Travis CI runs some more tests in those repos about, did this new SDK break any of the integrations? Do all the endpoints work like they used to? If you're changing the templates and changing the specifications, they might not. Each language template works a little bit differently. They all have different contributors. It's a very active project. You can contribute to them. We've made a few contributions back to the project. And so it's important to have these tests to make sure I made this change to the specification and my templates are still working. Because a lot of times there'll be changes lockstep between new features and specification to new Swagger CodeGen versions. And so if you try to use some unsupported feature, then if you don't upgrade your templates, then it's not going to work anyway. So an important thing to sort of keep in mind there. So that's kind of the general overview of everything. Here, one last sound. And so some of the pros to this, right, is that our team acts as a thin layer across many other teams that are actually working on the APIs. And so we don't have to worry about becoming a blocker for any of these other teams. Almost all the work is done automatically. And so if you're on some upstream team and I want to release a new endpoint, it's okay, well, you updated your proto, right? And so that goes through Travis CI, hits our specification, or then goes through Travis CI, it goes to all the repos, and becomes a new SDK for everyone to use. So it's great if you don't have a bunch of people you want to dedicate to this kind of work. Not so great if you want that bespoke, handcrafted experience, right? Sort of, if you can imagine generating an SDK, it's not going to be the most idiomatic code you're ever going to see, right? It's really a template file that gets mashed over and over again. So there's some complaints about oh man, this Ruby SDK looks a lot like a Java SDK. And it's well, yeah, think about how it was made, I guess. But it's better than no SDK in our minds. So yep, our developer relations team is hiring. My name's Tristan. Feel free to reach out to me if you are interested more in hearing how we do it, or you want to get a job. But yeah, thank you.